Hello students, welcome to Educate. In the last class, we have discussed about the percentage composition. In this class, we will discuss about stoichiometry and the stoichiometric calculation. So what is stoichiometry? Listen here. About this one we will discuss. Let's see. Like when hydrogen reacts with oxygen and there is formation of water. How to balance them? This one. So in this case, the stoichiometric coefficient of hydrogen is 2. Here 2 is written. The stoichiometric coefficient of oxygen is 1 here. And the stoichiometric coefficient of water is 2. Stoichiometric coefficient here is stoichiometric coefficient coefficient is 2, 1 and 2. Okay, that is, so based on this stoichiometric coefficient, what the calculation will be there? That will be stoichiometric calculation. Okay, let's see, we balance the chemical equation and then what we write to balance that, that is called their stoichiometric coefficient. Let's see here, based on that, what is the limiting reagent? Limiting reagent are the chemical species which will fully consumed in the reaction and hence limits the reaction. Like in the previous reaction, hydrogen was reacting with oxygen. So if hydrogen will get consumed, how much hydrogen? Limited amount, that means an amount of hydrogen will be taken and an amount of oxygen will be taken. And during the reactions, if hydrogen will get fully consumed, then how much water will produce? That will depend on the amount of hydrogen. So in that case, hydrogen will be the limiting reagent. In the same way, if oxygen consumed completely, then how much water will produce? That will depend on the amount of oxygen. So in that case, oxygen will be the limiting reagent. This one will be more clear by solving the numerical question. Okay, so limiting reagent, only that much, right? Limiting reagent is, what is that? In only one line. In the examination, questions should not ask what is limiting reagent, but what is that? What is that? You should write. You should know. So limiting reagent is the reactant So how much product will form? That will depend on the amount of limiting reagent. And about the limiting reagent, you will get more clearance when you will solve the numerical question here. More than the numerical question you will solve, more be your concept be clear. So few questions I shall solve. Let's see here. Let's see. Okay, let's see here this question. Question number 1.5. Based on that, question number 1.5 is identify the limiting reagent. That will be this one here. That is, in the question here is 50 kg of nitrogen reacts with 10 kg of hydrogen and there is formation of ammonia. You will have to calculate how much ammonia will form, and in addition to that, how much limiting agent will produce. Okay, so what will be the limiting reagent about that? Something, let's see here. So how the reaction is taking place? Nitrogen reacts with hydrogen. So let's see here. Nitrogen reacts with hydrogen and there will be formation of ammonia. That is the balanced chemical equation. Amount of nitrogen here how much? 50 kg. That has been given. Amount of nitrogen 50 kg. Hydrogen how much? 10 kg. Yes, 10 kg. Okay. Here I have written only which has been provided by the questions. Now let's see. Goes on the reaction. Nitrogen here. So atomic weight of nitrogen is 14. 2 nitrogen. So 28. 28. 1 mole of nitrogen. Watch out the reactions. 1 mole of nitrogen reacts with 3 moles of hydrogen. 1 mole of nitrogen molecule react with 3 moles of hydrogen molecule, and there will be formation of 2 moles of ammonia molecule. In this equation, by the equation you can predict that 1 moles of nitrogen molecule reacts with 3 moles of hydrogen molecule, and there is formation of 2 moles of ammonia molecule. Okay guys, so what happened here? So let's see, according to their weight you can find out also. Or here number of moles of nitrogen you can calculate. Number of moles of nitrogen will be how much? 50 kg means 50 to the power 3, that upon nitrogen 28. So that is, divide here, what's the number of moles of nitrogen will be here. So either there is two way, that either you firstly calculate the number of moles of nitrogen and establish a relationship between the number of moles, and other way is you establish a relationship in terms of weight. So here number of moles of nitrogen is here 50 into 10 power 3 upon 28. That much gram here it is, and it is gram per mole. That means U or gram per mole. Molecular weight of nitrogen is 28 U or 28 gram per mole. So 28 U or 28 gram per mole. So when you divide that, then you will get 1.78. So that will be 1.78 into 10 power 3. Number of moles of nitrogen will be that much. Now, number of moles of hydrogen will be how much? That is 10 kg. So 10 means 10 power 3 upon 2. So number of moles will be that much gram, and here 2 gram per mole. That means 5 into 10 power 3. So now watch out the reactions. Here 1 mole of nitrogen molecule will react with 3 moles of hydrogen molecule. So that much nitrogen is here. So that much will react with how much? That we will have to proceed. So that means here, according to the equation, as the equation is providing, so 1 mole of nitrogen N2 reacts with 1 mole of N2 reacts with 3 mole of H2. You have how much? 1.78. So 1.78 into 10 power 3. That mole of will react with 3 into 1.78 into 10 power 3. Mole of H2. So now calculate that. 3 into 1.78. Calculate. Multiply that. 3 into 1.78. That will be 5.35. 5.35. So 5.35 into 10 power 3. That much mole hydrogen. So 1 mole, that means how much nitrogen available there? Nitrogen available is 1.78 into 10 power 3 mole. So that much nitrogen will react with 5.35 into 10 power 3 mole hydrogen. But that much hydrogen is not available. That much hydrogen is not available here. So that's why nitrogen will be the limiting reagent here, but that much hydrogen is not available here. That's why hydrogen here is the limiting reagent. Oh, I told nitrogen. So that much hydrogen is not available here. That's why hydrogen is the limiting reagent. Clear here? So now, how much ammonia will produce? That will depend on the amount of hydrogen. Okay? So 3 mole of hydrogen gives 2 mole ammonia. 3 mole hydrogen, that is the limiting reagent, and hence the amount of ammonia produced will depend on the amount of hydrogen available here. So 3 mole of hydrogen gives 2 moles of ammonia, and you have 5 into 10 power 3 mole hydrogen. So how much will be there? So that's we will have to calculate. So here we will write 3 mole 3.3 into 10 power 3 mole ammonia will produce. So that is in terms of number. In terms of weight, how much? That you can also calculate. So you can also calculate weight of ammonia produced. So number of moles is 3.3 into 10 power 3, and here molecular weight is here, or molecular weight is of this one is how much? That is 17 ammonia, 14 for hydrogen and 3 14 for nitrogen, and 3 into 1, that is for hydrogen. So 17, that into 17. So multiply 17 by 3.3. That is how much? Calculate. So 56.1. So 56.1 into 10 power 3 gram. So when you have to convert into kg, so that will be 56.1 kg. So ammonia produced will be 56.1 kg. How much ammonia will be how much nitrogen will be unreacted? Next question. This one here, that one is sufficient for your 11th class. But when you will appear in the complete examination, question may ask how much nitrogen will be unreacted. During this reaction, hydrogen will completely consume. So let's see here. So 5 into 10 power 3 mole of hydrogen will react with how much nitrogen? That you will have to find out. Okay, let's see here. I am telling you also. This one calculated. Firstly write that, and then after I shall tell how much nitrogen will be unreacted there. There will be how much nitrogen unreacted. Let's see, I am also discussing how much ammonia. So that means 5 into 10 power 3 mole of hydrogen will react completely there. And okay, hydrogen will be how much? So let's see, it goes on this one. So let's see, 3 mole of hydrogen reacts with 1 mole nitrogen. 3 moles hydrogen react with 1 mole nitrogen. So you have how much? 5 into 10 by 3 mole hydrogen. So 1 mole hydrogen will react with how much? 1 by 3 mole nitrogen. You have 5 into 10 power 3. So that much mole nitrogen will react with how much? 1 by 3 upon 5 into this much mole nitrogen. Okay, so weight of nitrogen unreacted, how much nitrogen will left during the reaction? So that much mole. Oh, goes on that, guys. How much? That much mole nitrogen will react, and how much nitrogen was there? So that minus this value, that much will be the number of moles of nitrogen unreacted. Okay, so during that reaction, 5 into 10 power 3 mole of hydrogen will react, and in that one, how much nitrogen was needed there? That much. That means how much nitrogen was there? Nitrogen was how much? Here, nitrogen was 50 upon 14 into 10 power 3. 50 divided by 14, how much? Fifty divided by 28. That is 2.08 into 10 power 3. Here is coming 5 divided by 3. That much nitrogen reacted, and 2.08 into 10 power 3 mole nitrogen was available there. That much mole nitrogen reacted, and amount of nitrogen taken, that is how much? That is 2.08 into 10 power 3. So number of moles of nitrogen left after completion of the reaction. Subtract 2.08 minus 1.66. That much in terms of mole 1.42 into 1.42 into 10 power 3. In terms of weight will be how much? 1.42 into 10 power 3 into 28. Multiply that will be that means 39.2 kg water will be nitrogen. So that means 50 kg nitrogen has been taken, out of which the 39.2 kg nitrogen will not react. How much react? That is that much into 28. This one is okay, guys. This question very easy actually. But here, if you will solve this question by thinking, then you will solve these questions very easily. What's the procedure to solve this question? If you will focus on that, then you could solve these questions easily. But if you will try to mug up how to solve these types of questions, then you cannot solve this question. That means for the moment, you could do that questions, you could solve that questions, but after that you could not solve, and maybe you will feel difficulty. So that was about the questions based on the stoichiometry and stoichiometric calculation. That was the topic of stoichiometry and the stoichiometric calculations. Okay, in the next class we'll discuss about the reactions in solutions. Okay, so that will be in the next class. It's all for this class. Thank you, Team Educate.